hello. I am sick. Hello. Okay, yeah. Shit. I don't know why, but man. Okay, hey guys. So we're gonna be learning how to make your mech walk, and to do that, we're gonna learn how. Oh my God, it's Doomsday. I am hot. I'm sick, and that's. Yikes. Okay. Private server should be in the description below. You can try to join that. Oh shit. Wait, what? You can try, try joining the link in the description below. If it doesn't work, I can try and friend you. Yeah, that's basically it. Okay, so how to make your Mac walk. So if you didn't have it already, you should have what's it called, your IK logic set up already. Like you should be able to get your positions like this, right? Using a position sensor. Yeah, your privacy settings, so if you go into your Roblox settings, and you can change your other settings. So you go to my settings, then you go to privacy, and then you scroll down until you can see who can make me a member of their private server. All you have to do is just make it so that it's set to everyone. That's basically it. But if you can't change that, then just let me know. I can add you. Yeah. Okay, anyways, okay, we're gonna keep moving on because okay, so just let me know if you want to join. I can add you. Just let me know your user. Just send your username, I'll add you. Oh my God, that's actually sick, brother. Looking cool. Okay, so if you haven't already, you can make sure your IK system is set up already. What we're learning today, we're gonna learn how to make your mech walk. So make sure you have your IK set up already. Okay, so we're gonna just ignore that. Okay, Taco Hunt. Okay, I'll add you real quick. Okay. Oh man. Okay, added. I sent you. Can you on sire? Right. Okay. Hey, you can always. I think the private server is in this description below, right? On sire. Yeah. Okay, so let's go back to build. What you need first, actually, you want to make like a clock, some sort of clock. So, and what that does is that, like, when you like press W, for example, it activates a clock, which is inputted into like the sine wave. That's basically like our X, our sine X, right? So we're gonna do that. So what we need is get a clock, put that here. And to make this work, we need to make it so that it subtracts itself when we're not using it. Okay, so basically what happens when clock minus clock, that's basically 0, right? So that means that like when it's not activated, sine would be 0. X would be 0, and then that would basically mean it would be deactivated. Okay, so, and then we need a switch box. Sorry, don't do this yet. I kind of forgot how to do this. Yeah, streams will be archived after I finish. So, okay. How do I do this? I kind of forgot. Okay, give me a sec. I kind of forgot. I'm gonna go back into my... Okay. If you didn't know, the advanced Mech uses this. So we're gonna load this real quick, okay? We go here, right? Clock circuit. Okay, ignore the boolean first, right? So clock goes into the off value, and then once it's activated, wait. How does this work again? I haven't played this game in a while. I forgot. Here, let's just copy this real quick. Logic tutorial. It's like I'm learning this again. Sorry guys. So okay. Fuck. Okay. Sorry. People in the server are saying I'm rude for swearing, and I am sorry about that. Okay. I should not swear. I should restrict my swearing. So. Okay. Anyways. Let's see how this works. Okay, so what we're doing is okay, we get our clock, right? And we get our numerical switch box. And we get a subtraction. This is what we need to make the clock that we need to make our mech walk. So right now we let's see here. We're gonna put our clock input into the first value input of the subtraction, right? And then we want our off of the numerical switch box. So input the clock into the off value into the numerical switch box, and then you want to connect the numerical switch box into subtraction. into the second value input. And what this does basically is that like when it's off, it subtracts itself, right? Okay, now one other thing you need to do is connect the output value, basically I'm sure it's of the numerical switch box to itself, to the on value, right? And what this does actually is that like when you activate it, it stops the clock, right, at its current time, and it subtracts the clock by itself. So like it'll subtract the current time with the time you subtracted by itself. So like when it goes up, it's subtracting itself. So basically it'll basically be like what's it called? Okay, I'm bad at explaining, right? So I'm gonna show you. I'm just gonna basically like show you like what it does. Okay. I think it's basically better to just show you. What is subtraction? Yeah, I know, right? I don't know what subtraction is. Okay. Shit. Okay. What does a switch box do? It switches between two values. Two constant values. I mean, two number values. My bad. Not constant, just number values, okay? Let's get a button. Oh my god, he has the face thing on. What the heck? Okay. Okay, this is the numerical switch box value, what's it called? Number display. This is a clock, this is a output, okay? So I'm just gonna get our text display. I mean not, wait, what am I doing? Okay. The clock is constantly making like a number, right? It's like it's constantly like going up, right? Because when you unanchor your build, it goes up by seconds, right? So 1, 2, 3, 4, 5, 6, etc., right? All the way till, I don't know, till how much you want it to go until you unanchor. It's not a delay. Delay is something itself. So this is output. This is our clock. And this is numerical switch. Okay, as you can see, right now, it's subtracting the numerical switch box with the clock, right? So that means it's gonna be 0. But when you stop it, it basically stops the clock for the numerical switch box, and the clock will keep going on, right? So basically, it's the clock minus this switch box. It is coding. Elite engineering logic blocks is basically coding. That's what you want to know when you play this game. Okay, and then when you like turn it off, it goes back to its normal value, which is the clock. And then if you Press it again, it turns on. It stops the clock temporarily for the numerical switch box, but the clock keeps going on, right? And then you basically get the current time every time, right? Now, how does this work? Okay, why do we need this? It's so we can input it to the clock. So we don't want our mech to keep walking when we don't want it to walk, right? We want it to stop when we like stop holding like W, or for example, right? So vehicle seat, right? Yeah, our vehicle seat. We need a condition, so shit. Okay. Equals. Constant. Not. Okay, now what we're trying to do is that, like, okay, get our throttle output, right? So it returns 1 if it's forward, returns -1 if it's reverse, right? Okay. Okay, so basically that means like when we're setting, it's true, it'll always be true. Like it'll output a true. We don't want that because we want it to be a not. So like when we press W or S, it won't equal to 0 anymore, and that'll basically invert the, what's it called, the true value into a false, right? I mean, whatever, right? So when this is false, this will turn true, right? When we're not walking, it's off. When we're walking, when either it's W or S, it'll turn on, okay? Can you do the same thing, like keybind and number thingy to go into defense mode? Yeah, you can probably do that, but I don't think you need a clock for this, right? You only need this for like animations. It's like I'll basically show you after like we get through this. Okay, we're sitting, right? If I press W, it activates. If you press S, it also activates. So either way, going forward or going backwards, it'll activate it. Yeah, we'll need this for the arms too, right? We'll basically need this for the walking animation. So that's why I wanted you guys to know this. It's a basic circuit, but it's really useful for like many things. Just not like walking, right? Just not for walking. It's not just for walking. You can use it for multiple things. Okay. Since we have that done, we have our conditions when we want it to activate. We can start making it to walk, okay? So what do we need to do for this? Okay. So that's our clock, right? What we need is we're gonna set it up real quick, okay? So like we're gonna do a multiplication real quick. We're gonna make 2 parts of the clock, right? An X clock and the Y clock, okay? So let's get our text display, put this here. x, this will be our x, this will be our y. We'll put this into here. Same thing here, yeah, okay. Constants. Basically, what this does is that, like, if we want to speed up the animation, just multiply this with like 2. Like, just make the number bigger. But right now we're making it 1, so that's like stays normal, right? Yep. Okay. How do you join? There's a private server in the description below. You can try joining that. Oh, right here. Okay. Well then. Okay. Cool. Wait, Sharou, you're here? I didn't know. What the fuck? Okay. Sharou. Oh my god, I haven't seen you in a while. Okay. Hi. Okay. I didn't realize. Okay. Anyways, so that's basically it. After that, connect your constants here, there. Okay, for the x one, we basically want to go from one number to the other, right? Like, for example, 5 to -5, right? Like in like a wave function, right? So we're gonna do that using sine. Get our sine. Put this into here. And then you multiply it again. with a step distance, okay? So this is gonna be our step distance. Text display. If you haven't checked out the logic for the starter mech, I highly recommend it because this is what we're going based off of it. Yeah, so if you checked it out, you'll probably recognize like step distance, the step height, etc. Right? We're basically remaking this, but I'm just trying to like teach you guys. What the? Okay, stepping distance. Will the new list function be useful for? Sorry, MK. What's MK? If you could elaborate on that. I haven't tried out the list function itself, but from other people I did hear that it was like really useful. Manual kinematics, possibly, like it's really useful apparently. So okay, number display. This will be our stepping distance, right? So change the number to like 5, for example, right? You want to make it go 5 studs, right? Connect the sign to here, and then we'll just see what happens. Okay. When we press W, it goes from 5 to -5 to 5 to -5. So that's what we want for our X clock, okay? Now what we need to do is now what we need to do, how do you explain this? Okay, now we need this tapping height, right? We want that circular motion, so we're gonna basically let's just put this to the side real quick. That's actually cool. I like wrecking ball. Ooh, oh my god. Okay. Now our Y clock, right? Same thing, but I think what we're gonna do for here is we're gonna like times it by 0.5. It's basically like half of your X value, right? So if you're doing like 2 for here, you want to make this like 1. Actually, here, I'll make this more simple for you guys, okay? Delete that. We're gonna go off of this, right? Do division. Okay. Get our constant. Our constant number. Get our 2. Put this here. And we just get our multiplication from here to here, okay? Let's move this a bit. Change this to clock speed. Animation speed. Right, that's fine. Okay. Oh my god. Okay. Lots of cool creations here. Okay, we're dividing this by 2, right? And that's our clock. We're gonna multiply it by sine. What do you mean this is made in game? Huh? Oh my god, what the heck? Oh, the suit, yeah, you yeah, I thought it was a Roblox bundle, for example. Okay. Next, yeah, our sign. Basically same thing, but instead we're gonna right, never mind. Keep doing the same thing, right? Multiply it with this is gonna be our step height. Stepping height. We're gonna okay, and we're gonna call it oh my god. I'm like stumbling on my words. I mean, when have I not? So we're gonna color this green because that's gonna be like our output to our vector blocks. Okay. Shut up, dragon. Okay. Next, our stepping height, right? And then what we need to do is we need to subtract this, right? With our leg height. And because the reason why we're doing this is because since our blocks are controlled by what's it called? vector magnitudes and you know, the turret handlers. We want the position to be like right here, right? Okay. Anyways, I don't know. I don't know what I'm talking about. You'll. I'm basically just showing you how to fish, right? The fish. I'm giving you the fish. Next. Okay. Put this here, subtract this by your leg height. And what is our leg height? So it's basically thigh length plus shin length. So they're both 26, so 26 times 2, that would be like 52. So we're gonna do 52. What the heck? Iron Giant. Is that Iron Giant? I don't know. I forgot. Anyways, that's our leg height. Let's see what happens. Yeah, -52 goes up. Goes down to -56. We don't want that. We don't want it to go down to -56 because that's that exceeds our leg height. So what we need to do is we need a modulo this. Is this modulo? No, modulus. Forces a number to be positive, so we're gonna do that. Put that here. Shit. Put that here. So it'll always be a negative number for our stepping height, right? So always like yeah. That's basically it. 51. I'll go to 51 and I'll stop at 52 but go back up again. Yep, see? 52. Okay, what you get it, right? Same thing. Now, what we're gonna do is, where's the seats at? Right here, right? Number display. What we're doing is trying to see the coordinates of our position blocks, right? Okay, now vector to number. Vector to number. We need that. We're manually getting our coordinates for our position blocks, right? So put this here. From the global to relative. X goes here. Y goes here. Z goes here. Oh great. Okay, my bad. We're just gonna rotate this. Oh god, I'm lagging. What the heck? What the heck? Okay. I can't see shit. Okay. Yeah, so 52, right? That's our... This is so scuffed. Okay. Yeah, so negative 50. So we want it to go up to like negative 40, right? Probably we'll change the stepping height to like 10, for example, right? How am I gonna note this down? Okay, what I'm trying to find out is like which coordinates for the global to relative is our y. I mean, is our stepping wait. What coordinates? Okay. How do I explain this? We're trying to figure out, because we're gonna input this to like a number to vector block, right? Our x and our y from the stepping height and our stepping distance, right? We want to know which axis to like input it in, because like as you can see, our stepping distance, I mean our stepping height is the z-axis, and our stepping distance is the x-axis, right? Because it's not the y-axis, right? Y-axis is the, what's it called? The sideways. So yeah, we're gonna just go back to build. Delete this. Let's change it to like 10, right? For the stepping height. Change it to 10. Stepping distance. Let's do like 20, right? I don't know. Okay. This will be our... Oh my god. This will be our output. So get our number to vector. Where is it? Number to vector, right? Our number to vector block is then, since we know that the stepping height is the z-axis, we're gonna put that into the z-axis. And since we know the x-axis is our stepping distance, we're just gonna put that into our x value. Y value is not gonna be used. Okay, so that's basically it, right? Hold on. Oh my god. I'm dying. Yeah, but yikes. Yikes. Okay. Anyways, so we're gonna remove this, right? We're gonna remove the input, right? And we're gonna remove the inputs, the vector inputs for these two as well. Probably for this one too, right? Okay, next. Get our number to vector input, I mean our output, right? And connect it to the vector magnitude and the turret handler. Basically those two, right? Let's see what happens, okay? So right now it's straight. The blocks are straight. So if I could sit down. Okay. Our giant is dying. Okay, as you can see, we have our circular motion here. It goes up to it lifts it up. Yeah, that's basically it. That's what we want. So yeah, hopefully I explained that well. I probably didn't. But how can you add another animation when you're sending a different signal? Okay, I'll show you. Addition block. That's basically all you need. Switch box chaining, addition blocks. Yeah, that's basically it. But okay, here, for example, we go vector addition. How am I gonna explain this? What have I used here? Yeah, switch box chaining, that's one. You can use that. If you want the okay, vector addition, right? Or let's do vector multiplication. Or vector switchbox. I think vector switchbox would work too. So vector switchbox. Remove this, right? Put this here. This will be our off, and then for example we want it to be like a this would be like another shit. This would be another animation, for example, right? We would have to input our coordinates manually. For example, this would be like, I don't know. Oh my god, get out of the way, okay. Bias. Okay, so this would be like, for example, 25. This would be 5. This would be, I don't know, 15. No, not 15. Negative 30, right? That goes into our Z, this goes into our Y, this goes into our X. Okay. Now, since we're switching between these two poses, right? One would be our walking, and one would be like this one static pose, right? And then we get a button. We need something to activate it, right? What the heck is happening? Okay. Activate it. Okay, we have our walking animation, right? But then if we wanted to like switch it to like another animation, just activate it, and then it's stuck there. Like no matter what we do. Sorry, hiccup. Like no matter like how hard we try to make it walk, it'll be stuck in that position unless you like turn it off, right? Switch box chaining, that's what's basically it, I guess. That's basically it. Same thing here. If you want to add more, 3 animations. Same thing. Put this here. I think it goes by priority, right? So for example, this one would be the first priority because it's the last one in the chain that's gonna be connected into our vector, into our IK logic system, right? This would be off, and then we get another one, or another animation, right? Or another static pose. this would be like, I don't know, -40. This would be, I don't know, we can do like 5. Actually, let's change this to like -10, right? This one will be prioritized more, right? So basically, if you press this while this one is on, that won't show up because this one is prioritized. Because it's the last one in the chain, in the switch box chain. So yeah, so this is working. Okay, we can't move this because we activated it. But then if we activate our third animation, where is it? Oh shit, I did not. Oops. Okay. Yeah, I did not put this in there. Okay. We're gonna try again. Just to see. Walking. Oh, we played our second animation, right? But if we activate our third one, and we can't turn this back on because this is not prioritized. This one is prioritized because this one is the last one in the chain. Like I said. Yeah, so that's basically switch box chaining. What Taco Hunt said, right? Did I say that correctly? Taco Hunt. Okay, yeah, whatever. We're gonna continue on. Okay, I think that's basically it. We're gonna try to make the animation speed a little bit faster, so maybe like 3. Okay, that's our walking animation. Yeah, thank you for showing up. It's okay. Next. We want to apply it to the second leg as well, but instead we need to apply like a delay or some sort, right? Well, to the clock. So what we're gonna do, we're gonna copy this, copy everything. Well, only up to the animation speedrun one, right? Copy this. This is gonna be our second leg. We need to add some sort of offset to it first. So animation speed, yeah, that's fine. But after that, we need like an addition block with pi, I think, right? With pi, that basically adds an offset to our animation speed. I mean our clock. and then we're gonna, what's it called? Do the same thing for the other leg. Let's connect these. Yikes. Okay. Let's see if it works, okay? Well, we have it, but like it's stuck here. It's like stuck at an angle. So, to fix this, we're just gonna like apply a switch box here. So instead of adding the addition, we put this here, we put the switch box here, and we want to connect this to on, so that like when it's off, there, constant. Same thing, we're just gonna connect the not value, the not boolean from our clock earlier. Put this here. Let's see what happens. Okay, it's straight now. Okay, I think that's it. That's what we want. Okay, now to make your what's it called? We want friction for our feet, right? So that's what we're gonna do. We're gonna make sure the friction is like 1, because we want it to like make sure that it like drags along the ground, etc. I don't know. We're gonna delete this. What is this? Disconnect that. Let's see what happens. Oh god. Now that's something that we don't want it to do, so right, we have to configure our leg, right? Because make this here. Make this off. Make this on. Turn this on. Same thing here. Turn this on. Okay. Should work now. What's happening? Yikes. Okay. We want this to be off. Okay, there you go. Should work now. Yep, it's straight now. Okay. Let's see if this works. Well, it's not really working. I think we need to make the torque of this like higher. So we're gonna get where is it? Here, our torque. Make sure it's high. Oh god, it's stuck. Move this up. Big Mac, Big Mart, Big Fart. What? LeBron James. Okay. We is this walking? It's basically walking. We're making it walk. Yeah, once it's on grass, it becomes better, I think. Okay. I think that's it for walking. If you want to like if you wanted to walk backwards, that's a different story. We'll have to change. We'll have to do a multiplication here. So if you want to walk backwards, get multiplication. Connect this here. Connect your throttle output into the multiplication here. Disconnect these. Put this here, put this here. Same thing. Put this here. I think that's it. Yeah, so we can make this walk. But if we wanted to walk backwards, there you go. It's basically playing the animation backwards. I think the friction is a bit too high for this one, so we're gonna change this to like maybe 0.6. Much more simpler than what you did. Yeah, for walking backwards, all you have to do is just make the animation play backwards, and we can do that by adding a negative into that. Now we just have to optimize it so that it actually like walks, right? We have the animation walking. How to use servos and logic on my Mech? I suggest going back into like the first stream. I have like I talked about it. I talked about servos and such in the first stream. Anyways, maybe like change this to 0.8. No, 0.8. Okay. Okay, now you might want like for example like a bend in your knee when it's like not walking, right? Like if it locks its leg like that, then I don't think it'll look natural. So we're gonna to change that, we want our leg height could be like, I don't know, maybe 50. We can do 50. No, wait, let's do 48, for example. No, 49. We can optimize the logic later. But what I want to show you is that you can add a bend to the legs if you really wanted to. There you go. It's walking better. Welcome back. Wow. You got it down, huh? Anyways, that's for the walking animation. Okay. What time is it? 12? I think I'm gonna end it here because like I'm kind of sick and I'm like dying right now. Okay. If that's okay with you guys. Yeah, okay. I'm dying. If you want to learn like servos and logic, please refer to my older streams. Yeah, okay, thanks guys. Oh my god, flus. I fucking hate flus. Okay. Sorry. Okay, bye-bye. Bye-bye. Yeah, I'm dying. Nice to see you, Sajo. Thanks for joining. Bye-bye.